You are given a signal xt, and it is given that the signal is a periodic signal with period 3. Let's say with respect to that period 3, the Fourier series coefficients are ak. Now the question is, you are given a signal yt that is related as integral 1 by 2 t minus 1 t plus 1 x tau d tau. What are the Fourier series coefficients in terms of ak? Can we apply some property here? Which property we can apply?
Differentiate both sides.
Differentiate both sides. Then
Shifting property.
shifting property. If we know this, and it is given that there is some more information is given, the signal is having zero average value. Xt is a signal with zero average value. Then what about this? Integration property. Can we apply the integration property? If xt is a signal having zero average value, we can apply the integration property. Is it?
Yes, sir.
Then what is the Fourier series coefficients? Is it ak by jk omega naught? That is integration property. And this is not valid for k equals to 0. For other values, this is the expression. Now tell me, if you are given this, can you find the Fourier series coefficients of this? Let's say bk.
Yes, sir.
What is that? Using the integration property. So can we write this as integral t minus 1 to t plus 1? This is as integral minus infinity to t plus 1 x tau d tau minus integral minus infinity to t minus 1 x tau d tau. Okay. So if we know the Fourier series coefficient of this one, then what about this? Is this shifted version of this? Look, this is integration with respect to tau, and this is the limit is t. So we can say that I am writing it as y1t. Okay, this is y1t. Now what is this expression for yt in terms of y1t? Yt is what? If this is y1t, what is this?
y1t plus 1.
It is y1t plus 1 plus minus y1t minus 1. Okay. So you can use the properties. You can find the Fourier series coefficient using properties, right? If you know the Fourier series coefficient of y1t, apply the shifting property, take the difference, you will get the answer. Is it? This is 2, this is 1, this is signal xt. This is the signal yt. Okay, 0, 1, 3. This is 1. And read that question carefully. You have to find first the phase angle ak. ak are the Fourier series coefficients of xt. You have to find the Fourier series coefficients of ak, and it is given that you should perform all these calculations without explicitly evaluating ak and bk. The question is not first find ak and then from that find the phase. Without finding ak, you have to find only the phase of that. Is it possible? You have to use some property of Fourier series. Can you find this using some property of this? What type of signal is this? Is it a real valued signal? Xt?
Yes, sir.
Xt is a
Yes.
real valued signal. Is there any symmetry there in that signal? Even or odd?
No, sir.
No. But if you shift it left by 1, xt plus 1, if you consider a signal xt plus 1, is it even signal?
Yes, sir.
Yes, sir.
Xt plus 1 is an even signal. You shift it left by 1, you will get an even signal. It is not only even, it is a real and even signal. Now, if you consider Fourier series coefficients of that with respect to period 4, let's say this is bk. Now, can you tell me what is the relation between this bk and ak? ak are the
BK
Fourier
is
series.
AK, JK omega E.
bk is ak into e to the power j.
K omega.
K, it is omega. Is it omega? K omega naught. What is that property? What is K? Yeah, K omega naught, isn't it? It is K omega naught into T naught actually. T naught is 1 here. So it is K omega naught, is it?
Yes, sir.
That is the time shifting property. Now, if you know now what is the relation between the phase angles of this? What is phase angle of BK? Is it this? Because the phase angle of this is K omega naught. So it is BK, phase angle of BK is phase angle of AK plus phase angle of K omega naught. Plus K omega naught. Is it? Now, what is the nature of this signal xt plus 1? It is a real and even signal. Real and even signal means what about its Fourier series coefficients? If a
All
signal
real.
is, it is real and even. If a signal is real and even, its Fourier series coefficients are also real and even. Is it?
Yes, sir.
If Fourier series coefficients are real, then what about the phase? What is phase? If you consider BK, this is real and even. That implies that BK is also real and even. Real and even. Real means what? BK. What is the magnitude of BK?
Mod BK.
And this is phase angle BK. What will be this if BK are real?
1.
1.
Is it 1 or 0?
Angle is 0.
Angle is 0. I'm talking about the angle. This angle is 0, isn't it? So can we say that this is 0?
Yes.
This is the Fourier series coefficients of xt plus 1. That is 0. Then what is phase angle AK? Is it minus k omega naught? Is it that?
Sir, phase of BK can be 180 degree also.
180 plus 180 degree, that won't change. So this plus, you can integer multiple of 180. That is the answer. That is also true. Okay.
Yes, sir.
So this is the answer. Without explicitly finding the Fourier series coefficients, using the property, we have found the phase angle of AK. Just one more part I will explain, that this one. Okay, so here you are given two signals xt and yt. it is given that xt Fourier series with respect to period 4 is ak and yt Fourier series representation with respect to 4 is bk. Now you have to find this. Which property you can use?
Convolution.
Convolution property. What is convolution property? If xt Fourier series, this one, what is the Fourier series coefficients of xt into yt? I am writing it as ck. So what is the relation
AK
between this?
convolution BK.
ck is ak convolution bk. Oh, sorry, it is not it is not the convolution property. You can find the what is xt convolution yt periodic convolution.
AK into BK.
It is
AK
ak
into BK.
it is ak into bk. It is not ak into bk. If you look at the property, I think it is t naught into ak into bk. Is it
Yes, sir.
Not.
t naught into ak into bk? This is ck. This is periodic convolution. Now tell me, what is this? Can we say that if xt convolution yt, that is periodic convolution, having a Fourier series coefficient, having Fourier series coefficient ck, does it imply that xt convolution yt can be written as what? Ck e to the power j k omega naught t? Is it? That is the Fourier series representation. If xt convolution yt is having Fourier series ck, we can write this as in this form. Now what is ck? So can we write this as summation k minus infinity to infinity ak into bk? There is a constant term t naught. I am taking it outside, j k omega naught t. Is it that?
Yes,
Yes.
sir.
Now, how is it related?
The value at t equal to 0.
Value at t equal to 0. So can we write this as what? In terms of xt and yt? Is it 1 by t naught xt convolution yt at t is equal to 0? Is it that?
Yes, sir.
Yes. Tell me, what is this convolution? You don't need even pen to solve that, pen and paper. You can, from this figure, without doing anything, you can find the answer. Tell me the answer. What is that convolution? Periodic convolution. You have to flip the signal, multiply those two, find the area. Is it? Area over one period. Tell me, what is the answer?
So -1 to 1 of xt.
It is overlapping will be from -1 to 1, isn't it? xt. What is the area then?
3.
Is it 3? 2 plus 1 plus half is
3.5.
it is
3.5.
it is 3.5. That area is 3.5, isn't it? 3.5 divided by 4. That is the answer. Is it? 3.5 divided by 4. That is the answer. Okay. And the third part, I am leaving it as an exercise. Can anyone quickly tell me what is the difference between 2 and 3?
So we'll need to modify yt to get that summation.
What modification you have to do? What is the
Y
Fourier
minus t.
It is y minus t. Y minus t is b minus k. Then what is the answer? It is xt convolution instead of yt, y minus t at, is it this? T is equal to 0. bk, you have to
Yes, sir.
replace bk with b minus k. That means it is x minus t. So what is this convolution? What is convolution xt convolution y minus t? What is the difference? Yt, from yt, how to get y minus t? You have to flip it. Is it? And for convolution, you have to flip it again. That means what?
Just
Same
multiply the
signal
Just
delayed by
multiply those two, find the value at, means find the area over one period. Is it that? That is the answer. Okay.